when sunlight passes through atmosphere,
atmosphere will be like water droplet.
exactly. So we have this rainbow formation in the after rain. You have n number of rain particles on the surface of the earth. So to each and every water particle, the light ray incident like this. After incidenting, it refract. After refracting, since it is incidenting the more than the critical angle, angle of incidence, if you are taking with water and air and water interface, that is more than the 48 degrees if you are taking, then the light ray, instead of refracting through the water molecule, it reflect back into the same medium.
Yes, sir.
Since it is a transparent homogeneous medium, the light rays which is entering, the moment which is enters, it starts dispersing into its constituent colors. Here dispersion is taking place as well as refraction is taking place. Along with the refraction, since it is incident with the more than the critical angle, it reflect back into the same medium.
Yes, sir.
Okay, so by dispersion it is splitting into constituent colors, and by TIR process it is reflecting back into the same medium. Again it is refracting here. Since it
Yes.
is refracting, sorry.
So your camera is
Since it is refracting, okay, after refracting the dispersive colors will form on the screen. Here in the nature, the sky is acting like a screen. On the sky you will have the Vibgyor colors will fall. This is due to the one water drop. Like this we have in the nature n number of water drop, like in a serial order. By this serial order we have so many total internal reflections and refractions. Due to that we have many rainbows formation.
yes.
This formed rainbow, if this is a surface of the earth, in the sense, since we are on the emi surface, we can see actually the rainbow forming circularly across around the earth. Okay, around the earth you will get the rainbow. But since we are on the hemisurface, we are able to see the half of the rainbow only we can see.
Yes, sir.
Okay, we are on a horizon or we are on the hemisurface, we can able to see the half of the rainbow. This is the way the rainbow formation takes place usually. Not only in this, we have one more option. There are multiple rainbows also can form. Multiple rainbows you can see that when near the waterfall and all, because in waterfall the water is coming in different directions, and if the sunlight falls in different directions, then through the water droplets, whatever the light is refracting, that refracts, then due to that more rainbows will form. The rainbow here, through one drop at times two rainbows can come. How it is, let us say this is a refraction, from their total internal reflection. Here itself, whatever this light is there, instead of refracting, this is already refracted. Certain times what happens, some amount of light reflect back into the same medium like this. After reflecting, again it will go under the total internal reflection process. Then again it comes back like this. After coming back, again it refracts.
Yes, sir.
Whatever refracted, the second refracted light rays and reflected light rays, it comes back like this. First we have V and loss at the R. Now here the second rainbow which has formed, here I will have the V and the next the down is R. Means the red color is comes in opposite side, not like a previous way. Why it is that rainbow, whatever the second rainbow is forming, that is an inversion of the first rainbow. Because
Yes,
that
sir.
light rays only is going back and reflecting back, no? That's why
Yes.
it is inverted. Whatever one after the other rainbow will form, that is always inverted to the first rainbow, remember, which is forming from the same water droplets. This is the way there is a possibility of two or more rainbows formation is in the natural process. Okay.
Yes.
Now Apart from this, the other natural process we are having scattering of light. What is the scattering of light? Scattering of light in the sense in our brain something we are imagining which is colliding with the balls and with the marbles, like that we will have a thought process in our brain, right? Now, so same like light is scattering. How light is scattering? This is the sun. From the sun, whatever the light is emitting, it is white color usually. This light, whenever it is passes through clouds or through atmospheric particles, very very tiny small particles. Okay, so this light, whenever it is trying to pass to the atmosphere, it disperses. After dispersing, it is trying to pass small atmospheric particles like this in different directions. So while it is passing, it is also dispersing and trying to refract through this all small particles. But here, while it is dispersing, we know that white color will be splitted into its 7 colors, right? It's 7 VGR colors it will be. But out of these VGR colors, from white color, through these small particles, only small amount of light, small wavelength. Who is having small wavelength? Of course, violet is also having the small wavelength, but here blue light is having more small wavelength. Violet is also having, but violet is absorbed, it is not reflected. But blue light can allow or easily can pass through these small particles easily. Whereas all other colors, red color cannot be, because red color is having the larger wavelength. It will not go through the small particles. But blue light is having the smaller wavelength, no? It can go easily through the small particles. Okay? So, when you have in your brain wavelength picture, you will understand very easy. But violet is also very smaller than the blue, but violet is absorbed by these particles. But blue color only reflect back to our human eye.
Yes.
Okay, only blue color is reflect back. So other all colors will be absorbed by this atmosphere. Therefore, the sky appears in a color of blue. Even ocean water appears in a color of blue. Okay, the scattering is nothing but the small amount of light which is passing through the tiny atmospheric particles is called as scattering. This scattering always, there is a formula beta, Rayleigh-Jeans scattering. Scattering always inversely proportional to the 4th power of lambda. Why 4th power of lambda? Means the wavelength is smaller. The more smaller wavelength, the more scattering light. Okay, if the wavelength is larger, then scattering will be smaller. Smaller the wavelength, blue light is having small wavelength, that's why blue light is scattered through each and every particles across the sky. So that is a scattering of light. Due to this reason only, we have one more important thing takes place in the nature. What is that? Sun horizon distance. Sun horizon distance means sun appears in the noon time is in white color when you are on the surface of the earth. Okay, when sun is at our overhead, it appears in a color of white because there is no deviation in the light, right? But sun is at horizon distance, either this side or this side. This is, we say it is horizon distance. Horizon distance is so longer beta. Since it is longer, whatever the object which you are seeing or which you are able to see in the sense, it is in color of red only. Why? Red color can be seen from longer distance also because of larger wavelength. Larger wavelength. Red color is having the larger wavelength. That's why the sun is appearing at the horizon distance in a color of red.
Yes, sir.
Okay, when you see evening times now at present, like sunset time and sun rising time, the sun is at the horizon distance only. It is appears in a color of red only.
Yes, sir.
Okay, that is the basic reason, because wavelength is larger. The stars which is appearing in the sky at longer distance, it is in a color of red only. Okay, it is not in a color of others, only red color appears because since it is longer distance.
Yes, sir.
Okay, but according to the Doppler shift, for example, this star is moving towards our earth. It is coming towards our earth, then it appears in a color of blue. Why? It is coming to our side, and at the same time wavelength is shifting larger to smaller. Okay, so that's why it is appearing in color of blue if it is moving towards your eye. That is called as Doppler shift. Okay, this is nothing but depends on its wavelength and physical properties of light. Next we are going to discuss optical instrument, which is most important